Above and below the Milky Way are two gigantic bubbles blasting out gamma rays, the most energetic light in the universe. It's only when we mask out both the bright objects and the glow from the gas and dust in the Milky Way that we then notice the emission from the Fermi bubbles. And it's very distinct emission too. It has a very different signature to the emission that we see from the gas and dust in the Milky Way. So a very different spread of energies of gamma ray light that the Fermi bubbles are emitting. There are much higher energies than we typically see given off by like the galactic plane of the Milky Way. To produce those high energy gamma rays, what we need are high speed electrons, accelerated to nearly the speed of light before they collide with a low energy photon of light, something like infrared or radio light. That collision slows the electron but adds a load of energy to the photon, producing a gamma ray. This process is known as inverse Compton scattering. And it's why we have very different signatures from the Fermi bubbles to the gas and dust emission from the Milky Way. Another distinguishing feature of the Fermi bubbles is that the edges are really clear. They are sharp-edged rather than fading out, suggesting a sudden release of energy is what caused the Fermi bubbles rather than a slow and gradual process. Not to mention the fact that the Fermi bubbles are absolutely huge. This is an image of the entire sky and the bubbles cover roughly 10% of that image. They're 50,000 light years long from top to bottom, which is half the width of the entire Milky Way galaxy of 100 billion stars. So, given everything we know about the bubbles, what are some possible explanations for the Fermi bubbles?